Okay, another theorem, okay? Theorem, whatever number this is. So, in this theorem, our statement saying if the angles subtended by a chord of the circle are on the same side of the chord, then the angles are equal. Okay? So, remember for what they're saying here, cause statements are the chord, right? Remember, a chord should be a line from circle to circle, I fit a cent. Okay? It can also be an arc. Remember, an arc get this part it will from this point to this point. Okay? They call this an arc. So, but most of the books they record because apparently this kind of a line or a make a sense, right? But anyway, either way, with this line or without this line, it can work as an arc or a chord. Okay, so but if the angles, which angles, this angle and this angle, okay, they are subtended by the chord, this chord, okay, they are subtended by this chord or by this arc, okay. So if these two angles are subtended by the same chord, and then which means these angles must be equal, like so required to prove here or prove these two angles are equal. Remember, the first thing you read rank construction. For this one, we're going to construct or we're going to make to find a center of our circle, like so you can just put a dot here and then just find a center of the circle, then construct from A. You can label this word O, then construct from A to O, then again construct from B to O again. Now it gave you a center, and then it also gave you this part another shape from A to O and then to B again. Okay? So if you can check unusual, we have another angle here, a new angle that was formed, right? So, and on our last theorem, the angle at center is twice angle at circumference. Okay? So it was something like this. This angle is twice this angle. So if at this part, at this part triangle, okay? If you can check it, it's the same thing as that theorem here, angle at center, twice angle at circumference. From here, it will more, then it offer the same thing. Or this angle is twice this angle. Okay? So, okay, let's get on with it. So we have angle O is equals to 2 of angle P. Okay? So the reason of this one is angle at center is twice angle at circumference. Okay? Then again, if it's all at this part, this shape still is at the same part from this point to A, and then from A to O, from O to B, and then from B to Q. Okay? So which means our angle O again is twice angle Q. Okay? And then you give it the same reason as that one you okay? Therefore, since reflected to this point, so which means both of this angle the O, okay? So which means our angle 2P is equals to angle 2Q. Okay? Then we can divide both sides. Then this 2 cancel this one cancels this one, then P is equals to angle Q. And then that's our theorem. Another theorem, angles in the same segment. Mostly this one we should show for reasoning or should show exam is angles in same segment. Okay? Hopefully, udra the notes make sure the notes are out of the